Hey guys, my name is Uma and welcome to another video. In today's video, I will be explaining the programming concept of recursion, but from a technical interview standpoint. Without further delay, let's get started. Simply put, recursion is the process by which a function calls itself directly or indirectly. It is a technique used to solve problems where the solution of the main problem depends on the solution of smaller instances of the same problem. Recursion is a key fundamental way to solving many programming problems. Now, it is worth noting that problems that can be solved recursively can also be solved iteratively, and oftentimes, solving them iteratively is simpler and straightforward. As a matter of fact, I would suggest that you first try to solve a problem iteratively, and then, when you're comfortable with the solution, you can then proceed to try to solve it recursively. I would still strongly recommend that you learn recursion because it is a key programming concept that is asked in many programming interviews. When you solve a problem iteratively and there's still time left in your interviewer is almost certain to ask you to solve the problem recursively to test your knowledge of the concept. With that being said, let's jump into some illustrations. There are two main parts of a recursive function: the base case and the recursive step. The base case is the point in the function where the solution can be stated non-recursively. It is the point where the problem is simple enough that it can be solved directly. Let's take the Fibonacci series for example. The formula for the Fibonacci series is as follows. F of n is equals to f of n minus 2 plus f of n minus 1, where f of 0 is equal to 0 and f of 1 is equals to 1. In this case, our base case will be for where n is equal to 0 and for where n is equal to 1, because for those cases, we can simply return 0 and 1 as the result. We can no longer break down the problem into any recursive steps. Translating this into code, we have if n is less than or equals to 1, we simply return n. This base step is also important because without it, our function will keep calling itself indefinitely until it runs out of memory or until we stop the program. We also start our function with the base case because with each recursive call, the first thing we want to check is if the current recursive call is at the point where we cannot break it down into smaller problems. This will ensure that we reach a base case. The base case also serves as a vital building block to solving the rest of the problem. This leads me to the second part of a recursive function, the recursive step. This is the part where we make the recursive call, that is, the part where we call our function again. This part comprises of three main components. The first part is divide. This is the part where we divide the problem into one or more simpler parts of the same problem. The second part is the call. This is the part where we make the recursive call with the smaller parts of the same problem. The last part is the combine. This is the part where we combine the solutions of the smaller problem to get a bigger one. Let's take a look at what this would look like for the Fibonacci series. The formula already shows us the first part of the recursive call, the divide. Say we wanted to get f of 2. From the formula, we know f of 2 is equals to f of 2 minus 2, where n is equals to 2, and f of 2 minus 1, where n is equals to 1. This would give us f of 2 minus 2 is 0, and f of 2 minus 1 is 1. As you can see, we broke down the bigger problem of getting f of 2 into f of 0 and f of 1, as dictated by our formula up here. We divided the problems into two smaller pieces. The next step would be to call our function with the smaller parts. This will look like this. We would simply call fib of n minus 2 from our formula up here and fib of n minus 1. As dictated from the formula here. The final step will be to combine the results of both calls so we can get the solution to the bigger problem. To do that, we would simply combine our answer from both calls and return it. And that's it. Another way you can understand recursive problems or recursive code is to draw the recursive tree and see how it breaks down into the multiple calls and how they come back together to give an answer. Let's take a look at that. Say we wanted to get f of 4. This will break down into getting f of 4 minus 1, which is f of 3, and f of 4 minus 2, which is 2. Now, we would then add the results of these two to get the result of f of 4. We would then further break down these calls until we get to the base case. F of 3 can be broken down to f of 3 minus 1, which is f of 2, and f of 3 minus 2, which is 1. F of 2 can be broken down into f of 0, which is 2 minus 2, and f of 1. F of 2 here can be broken down into f of 0 and f of 1. As you can see here, we called f of 2 twice, once here and once here, in a situation where we have multiple calls to make. Making duplicate calls can be detrimental to the performance of the function. To fix this, we would store the results of previous calls we've made. So when we come across a call, we would check if we've made that call before, and if we have, we simply get the result of that call rather than making that call again. This is a process known as memoization, but more on that in the next video. Let's take a look at how these calls will percolate to get back up to the bigger problem. Well, f of 0 is 0 and f of 1 is 1. These two would combine to give us the result of f of 2, which would be 1. F of 0 is 0 and f of 1 is 1. These two will combine to give us the result for f of 2 here, which would be 1. F of 1 is 1. So these two would combine to give us the result of f of 3, which is 2. And f of 3 is 2 and f of 2 is 1. Now these two would combine to give us the result of f of 4, which would finally be 3. And that is how we get the final result for the question of f of 4. Finally, I want to go over a recursive problem that involves backtracking. This technique usually comes up in problems that require you to make a combination of some sorts. This would mean you would have to pick a path and explore multiple options while keeping track of where you've been. So when you come back, you can then pick a different path and explore multiple options as well. The main thing to keep track of is the order of the recursive calls, and understanding that each recursive call has its own memory in the call stack. And by memory, I mean its versions of variables and where it is in the sequence of executing the code in the function. The problem we're going to be looking at is a tree traversal problem. It is a very popular programming problem. There are three main ways you can traverse a binary tree: in order, pre-order, and post-order. Traversing the binary tree in each of these ways will produce a different outcome. Let's take a look at the pre-order outcome. Traversing the binary tree in a pre-order manner would print the following results: 1, then 2, then 4, then 5, then 3. Let's take a look at how this would work. We would do this recursively. As I stated earlier, the first step in any recursive problem is the base case. In this case, the base case is if a node is null, we simply return because there is no more work that needs to be done. When this function starts, we would pass in our root node. Passing 1 into our function, the first thing we would do is check if 1 is null. Well, 1 is not null, so we would skip this statement here. We would then print the node's value. The node's value is 1. The next step would then be to go to this line, where we call our recursive function, but passing in our current node left child. Our current node's left child is 2. Now, when we make this call, we would start the function again, but for a different node. So when we pass 2 in, we would first check if the node is null. The node is not null, so we would skip this step. We would then print the node's value, which is 2. After passing 2, we would go to the next step. We would then make the recursive call and pass 2's left child in, which is 4. Again, like 2, we would do the exact same thing. We would check if the node is null. It's not null, so we would skip this step. We would then print the node's value. In this case, it is 4. The next thing we would do would then be to pass 4's left child in. Well, 4's left child is null, so when we pass it in, it would come here. Since 4's left child is null, we would simply return. When we return, we'll come back to this step because this was where we passed 4's left child in. We would then pass 4's right child in. Again, remember, the execution of the function must continue. When we make a recursive call, it goes into the function. Then it finishes the execution. Then when it comes back after finishing its execution, it must execute the rest of the lines of the code below it. So we would then go in and we would then pass 4's right child. 4's right child is null, so we would simply return. Then we would then return from 4's execution since we're done with that. Now we would then go back up to 2's execution because it was from 2's left child that we got into 4. We would then call the next line in 2's execution, which is to pass 2's right child in. 2's right child is 5, so we would pass 5 into our function. The next thing we would do is we would then check if 5 is null. Well, 5 is not null. We would print 5. We would then pass 5's left child in. Well, 5's left child is null, so we would simply return. Then we would come back to this point in the function again and pass 5's right child in. 5's right child is null, so we would simply return again. Then we would go back to 2 because it was from 2's right child. It was from going right on 2 that we were able to get to 5. Well, we just went right on 2. That's how we're able to get to 5. So there's no more execution for 2 to do anymore. Then 2 would then return back up because it was from 1's left child that we were able to get to 2. Well, 1 was here when we left. We would then execute the right side. We would then execute the rest of the function for 1's execution, which is to go to the right node. The right node is 3, so we would then go in. Well, 3 is not null, so we won't return. We would print 3. Then we would be here for 3's execution. The next thing we would do is we would then pass in 3's left child, which is null, so we would return. Then we would come back here and we would then go to this function. We would then pass in 3's right child, which is null. We would be done with the execution of 3. Finally, we would then come back up here to 1, and that's the end of the function. Recursive functions usually come in more ways than I've listed, but the general idea is the same. It should always have a base case and a recursive step. And in the recursive step, you should be looking for ways to break down the problem into smaller problems of the same type. You should then look to make recursive calls and combine the results of the smaller problems to get to the bigger one. As with everything in life, practice makes perfect. Practicing more problems that involve recursion will help you understand the concept, and you will start seeing the patterns in these problems. It may be hard for you to understand at first, but drawing out the tree of the recursive call will help you understand and visualize the problem. And after you've done this enough times, you will start seeing the patterns in the problems to the point where you won't need to draw it anymore. If you have any questions, feel free to leave them in the comment section and I'll be sure to answer them. If you're new here, I make videos like this explaining programming concepts, solving technical interview questions, and building apps and projects and showing you how I build them. If you're interested in stuff like this, feel free to subscribe so you don't miss a video. Thanks for watching and see you next time.